Hello, welcome back. Today we are going to continue simplifying expressions, but we are going to be using the quotient rule today. Go ahead and add in on your table of contents the quotient rule. I'm on page 47 and 48. Okay, our objective is to simplify expressions using the quotient rule. And our essential question is, what is the quotient rule? So go ahead and pause the video to get all of this written down. Okay, our steps are very similar to the product rule, but instead of multiplying, we are dividing, because quotient means to divide. So we divide those coefficients, and then instead of adding, we are going to subtract exponents with like bases. So that's the difference between the product and the quotient, because product means to multiply, quotient means to divide. So focusing on the quotient property of exponents, if I'm looking at algebra, okay, the algebra rule, I'm going to follow that. Well, I don't have any coefficients, but I do have like basis, so I have like basis e, and then my exponents are n and l. So we take those like basis of e and we subtract those exponents. Okay, so our example here, we end up with e6 minus 2, which would simplify to e to the 4. Okay, and then the reason this works is because if I were to write all these out, e times e times e, so we're multiplying 6 e's on the numerator, and then on the denominator we are multiplying 2. Well, what happens if we divide something by itself? So if I divide e by e, they cancel. Okay, so I'm left with 4 of them. So e raised to the 4th. Okay, so think of it, remember, variables are just numbers that we don't know. So let's say e is 4. So 4 divided by 4 is 1. So that's why I can cancel those out. Okay, again, feel free to pause this video to write that out. Let's take a look at some examples. So the same thing, if it says to simplify the expression, you need to actually calculate it. If it says to simplify and leave as an exponent, then we leave it as an exponent. So be careful and read those directions carefully. So here, my like base is 2. My exponents are 3 and 2. So I'm going to have my base, and then I'm going to subtract 3 minus 2. So this is going to simplify to 2 to 1, or just simply 2. Okay, let's look at the next one. I have a base of 3. My exponents is 7 and 4, so I'm going to get 3, 7 minus 4. So that's going to be 3 to the 3rd. Okay, well, let's actually go one step further and fully simplify this. So that means 3 times 3, which is 9, times 3, which is 27. So this one would actually simplify to 27. Okay, this next one, I have a base of x. My exponents are 10 and 4. So this is going to simplify x, 10 minus 4. So I'm going to get x to the 6. Again, if this is confusing how I'm doing the math, it's okay to write that out. Meaning, I'm going to have 10x's over 4x's. And then we know that when we divide them, so I'm left with 1, 2, 3, 4, 5, 6. So this would be x to the 6. Okay, it's totally okay to write it out if that helps you visualize it. Okay, next one, we have like bases 5 and 5, and then we have like basis y and y. Okay, now here I'm going to simplify these 5s as, even though they are coefficient, I'm going to simplify them with exponents. So I'm going to get 5, and my exponents here are 12 and 7. So 12 minus 7. And then y, I have exponents 20 and 8. So I'm going to get y 20 minus 8. So 12 minus 7 is 5. So I get 5 to the 5th. And then 20 minus 8 is 12. Okay, but I can simplify 5 to the 5th further. So 5 times 5 times 5 times 5. So 5 to the 5th becomes 3,125. You can do that in your calculator. All right, see if you can simplify 5 and 6. Hopefully at this time you paused the video and you worked these out. So for number 5, I have a like base of x, and my exponents are 7 and 2, so I'm going to get x 7 minus 2. So this would simplify to x to the 5th. For number 6, our base is x. Our exponent is 13 and 5, so that's going to be 13 minus 5. So 13 minus 5 is 8. Okay, so here I have coefficients without exponents. So my coefficients, we need to divide. And then I need to take my bases and subtract those exponents. So if I were to write that out, I would have 27 divided by 9. And then I'm going to end up with k, and I subtract those exponents, so 10 minus 6. So 27 divided by 9 is 3, so I get 3k, and then 10 minus 6 is 4. So this one simplifies to 3k raised to the 4th power. Well, what happens if my numerator is greater than my denominator? It's basically just reducing the fraction. So we get 6 divided by 30, which we can't do, but do they have a common factor? Yes, they do. So they both can be divided by 6. Okay, and then my base here, we have n and n. And then I have my exponents of 5 and 3. So this would be 5 minus 3. So 6 divided by 6 is 1. 30 divided by 6 is 5. And then I have n to the second. Well, that kind of looks a little funny. Remember, we don't need to write a coefficient of 1. So really, this simplifies to n squared over 5. That's how we would write that. All right, a couple more, a little bit more challenging. So I need to divide coefficients. So that means I have to divide 42 by 6. So I'm going to write that out. And then I need to pick out my like basis. So I have f, and the exponents there are 8 and 5. So that means I'm going to have f 8 minus 5. Now I also have like basis g and g. Well, when we have the exponent is greater on the denominator, we leave it on the denominator. So which means I'm going to have g, and then with my exponents being 6 and 7, I'm going to have 7 minus 6. And see how that stays right on the denominator. It stays where the larger exponent is. So now let's actually simplify this. So 42 divided by 6 is 7. So I have a coefficient of 7. I have f, 8 minus 5 is 3. And then on my denominator still I have g. And then 7 minus 6 is 1. We don't need to write the 1. So it would just be g. So my simplified expression here is 7f to the third over g. Okay, my last example here, I have coefficients 12 and 32. Then I have a base of c with exponents 9 and 4. And then I have a base of d with exponents 6 and 3. Okay, well, 12 and 32, I can't divide evenly, but I can reduce. So what can go into 12 and 32? I recognize that 4 can. You could even do 2. So we're going to reduce this. So 12 divided by 4 is 3. 32 divided by 4 is 8. So that means this is going to reduce to 3/8. Then I have c, 9 minus 4. And then I have d, 6 minus 3. So we get c to the 5th and d to the 3rd. So you can leave it as 3/8 c to the 5th, d to the 3rd, or we can write this as a fraction, which is how we'll see it. So 3 c to the 5th, d to the 3rd, and then our denominator is 8. Okay, if you have any questions or didn't understand anything, please make sure you get them answered. You are ready to move on to your assignment for today.